All right, first section of chapter 4 is classifying triangles. This should be the easy part because there's only one answer. There's no real ways of getting confused. So the objective is to classify triangles by their angle measures and side lengths, then use triangle classification to find angle measures and side lengths. Here's your vocab. Recall that a triangle, that's the symbol for a triangle, is a polygon with 3 sides. Triangles can be classified in 2 ways, by their angle measures or their side lengths. So this is a triangle. Let's call this A, B, C. AB, BC, and AC are the sides. So AB, BC, AC, pretty self-explanatory. A, B, and C are the vertices. The vertices are where the angles are going to be formed. So we can call this angle C, or we can call it ACB or BCA. So there are 3 different things to call this angle right there. All right, so the first type is your first buzzword, acute. Acute triangle has all angles are 3 acute angles. So they're all less than 90. They are all less than 90. Equiangular triangles are all the same. All the angles will always be the same. A triangle has 180 degrees inside the triangle. So since it's got 180 degrees, all of these are the same. So equiangular triangles will always be 60 degree, 60 degrees, and 60 degrees. All of their angles will always be 60, 60, 60. All right, and the third one is a right triangle. One angle is a right angle. And again, right angles mean 90 degrees. So if there's a box here, so it's a right triangle. These two will be various measures. They could be the same measure, they could be different. Obtuse, one obtuse angle. On this diagram, this one is the obtuse. So this is also an obtuse triangle. That one's a little more obviously obtuse. And stuff like that. All right. Classify triangle BDC by its angle measure. So first we need to find BDC. There's a big triangle, a small triangle, and a medium triangle. So we start at B, we go to D, we go to C. So we're going to be looking at the medium triangle. Since this medium triangle right here is 100 degrees, this is going to be obtuse. Classify ABD. Now we've got the small triangle, A to B to D. This is going to be 20, 80, and because of linear pairs, this is also 80. So it's 80, 80, 20. Since all the angles are acute angles, this is going to be an acute triangle. All right, now we can classify them by their sides. If they have these tick marks, they mean they are all the same measure. That's what the tick marks mean. So the 3 congruent sides we call equilateral. Equi means the equal, lateral means the sides. Equal sides. Isosceles. Isosceles means there's at least 2 congruent sides. At least 2. If it has a third one, then it's equilateral. So 2 equal sides is isosceles. 1 equal side, or 3 equal sides is equilateral. 2 equal sides is isosceles. No equal sides is scalene. This is your second buzzword, is scalene. So scalene, there are no equal sides. Isosceles, there are 2 equal sides, and equilateral, there are 3 equal. When you look at a figure, you cannot assume segments are congruent based on appearance. They must be marked. So if I drew this, it looks like it could be equilateral or isosceles. But until I put this, you cannot say that they are. Now that that's in there, you can say, oh, that's isosceles. But until they put those tick marks, if those tick marks aren't there, you can't say that. So now I can say it's isosceles, or now I can say it's equilateral. So you have to have the tick marks there. All right, so classify EHF by its side lengths. So let's find EHF. We've got E to H to F. So I'm looking at this medium triangle right here. I see that this has a tick mark and this has a tick mark. This one does not. So it's going to be isosceles. All right, classify EHG. EHG, so this is the big triangle. First I need to figure out what the length of EG is. I got 2 numbers. Segment addition postulate tells me I can just add the numbers. So EG is 14. The whole length is 14. So I have 14, 12, and 11. Since they're all different, it's going to be scalene. All right, last example. Find the side lengths of triangle JKL. How on earth am I going to do this? Well, since I know that these are congruent, I know this is an isosceles. So what I might want to try to do is set things equal to each other. Since the segments are congruent, their values are going to be congruent. So I set 4x minus 10.7 equal to the 2x plus 6.3. And now I can just simply solve for x. I'm going to subtract the 2x. And I get 2x minus 10.7 plus 6 equals 6.3. Add the 10.7. And I get 2x equals 17. Divide both sides by 2, x equals 8.5. So the hard part's done. I found what x equals. Now I just have to put this back into the equations because they want the side lengths. That's what they're asking for. They don't care what x is. So now I just simply have to put in what JK is. JK, I put in 8.5 for x, and I get that it's 23.3. Again, JK is right here. I'm putting x in for this, and solving, you should get 23.3. Now when I solve for KL, I should get the same answer because it's isosceles, and that's what those tick marks mean. So let me put 8.5 in for x. 8.5 times 2 plus 6.3 is 23.3. So that is good. That should have happened. It's not a surprise that that happened. All right, and now let's find JL. 5 times 8.5 plus 2 is 44.5. So this is your answer right there. So because this was isosceles, I set them equal to each other to solve for x. If it was equilateral, I could have set any of them together. If it was scalene, I wouldn't have been able to solve for it. And that's it.